Good afternoon. Sorry for having to use a video for the first couple days for the first day of notes, but something pulled me away. So I want us to think through to start, and we're going to do a very, very, very brief introduction today. So to start with, I just want you guys to think through, where does learning start? Okay, and so as we think historically, as we go back, way back when, obviously I think about the world through a math lens. And at some point, somebody developed algebra, and at some point, somebody developed statistics, and at some point, someone developed biology or the written word. And all of those things come back to two major things. We always start with a question of interest and communication. So as we developed language throughout history, it was so that human beings could communicate with each other in a way that everybody understood what was going on. And then usually as we develop things, it's because someone had a question and wanted to figure out what would happen or how things interact with each other. So as you're thinking about the social sciences, history is all about, the study of history is about studying how different conflicts happened and why they happened. And so all of this comes back to how and why, and those are question words. Okay, and so statistics was one of the later maths to be developed for a multitude of reasons. But we have a specific kind of question called a statistical question. And when we look at a statistical question, we have to decide, what makes something statistical? Well, I could look around the room and I could say, how tall is blank? And depending on the student, for any one student, that answer has exactly one answer. And so if we were to say, how tall is Meister? The answer is 5 foot 1 inches after yoga. So, but if I were to say, how tall is the class? That's a much more difficult question to answer, because as you look around the room, you might start to notice that, hey, we don't have people who are all the same height. Okay, so a statistical question is one that expects variability. In other words, not all the answers are going to match. Okay, so we're going to use the word variability a lot. Okay, so in layman's terms, variability is that not everybody gives the same answer. In statistical terms, we call that variability. Okay, so I'm going to go ahead and give you guys about a minute, and I want you guys to each write down a statistical question. Now, as some of you might have experienced, coming up with a statistical question is actually a little bit more challenging than what we would think. So as we go through and we start thinking through about things statistically. One of the things I want you to start thinking through is, formulating that question. This is the foundation. Because if you don't ask the right question to start and you gather your data is meaningless. Okay? So you have to come up with a good question first, because if you're asking the wrong question, then your data won't answer the question that you need to answer. Okay? Then you want to gather your data. And this is actually more complicated than you would think. You really are going to want to think about how to gather that data and what data you're going to gather. And when it comes to analyzing data happens a lot of different ways. It includes graphs, includes calculations. And when you think about the statistics units that you've done in your other classes, okay, while not focused 100% on this, most of what you do is analyze data that's already been given to you. So the big jump from, say, an Algebra 2 statistics topic versus this AP class is you're going to find that we're going to be thinking, we're not just going to be analyzing that data, but we're going to be thinking through where did it come from, or how can we make sure it fits what we need it to fit, okay? And then lastly, we're going to finish out with making a conclusion. And I like to think of the conclusion as the so what. So if I tell you that the mean number of students in Miss Meister's classes this year is 13.8, so what? We have to make a conclusion from that. Like, wow, that's a really low number. Or, wow, that's a really high number considering she's teaching such high-level courses. It really just depends. And so the whole purpose of making a conclusion is making sure that we're finding value in that analysis that we've just done. So let's talk about the language of variability and variation. So at the beginning of class, I asked you guys to take a survey based on some questions to help me understand you guys a little bit better, but also for you guys to get a feel for some data, some statistical questions. And then also my goal for that is I will use that data to create notes throughout the school year so that when we are learning about these different forms of analysis, when we're learning about how data is gathered, we're hopefully going to be able to use that data and maybe make notes more interesting. So, what were some of the questions that I asked you guys? Well, there was the one about the toilet paper. Which we'll see if that has the effect I hope it does. We'll see. If there were questions about how long it took you to get to school. And all of these, we all have different answers. And so you might expect that for myself, my commute time, since I don't live in Grandview, will be bigger than, say, your guys' commute times. I mean, this is an example of some of the things that, when we talk about this, they're not the same. So I want you to just pick a couple of the questions that you guys answered on that survey and just confer with the person sitting next to you or someone nearby and say, did you have the same answer? And is that surprising? And while for some questions, I believe that did you have the same answer was yes, for the majority, I bet that answer was no. And is this surprising? I think that answer is also no. Since we're all different people, we have our own natural variabilities. We would expect to not get the same answer, okay? Because they're statistical questions. All right. Now, as we start learning about statistics, what we're going to be doing is statistics is about, we're going to use probability to explain variation. Okay? Now, on that survey you just took, you were asked about both categorical and quantitative variables. Okay? And so I want to kind of go through, sometimes in your science classes, categorical variables are called qualitative variables. Okay? In the statistics world, we tend to say categorical instead of qualitative. So this brings up a good point as what you can expect this year. Science definitely has some different verbiage than statistics. Even statistics is different from algebra. So there are going to be times where we use different names for types of variables. And I'm always going to use the proper statistics words for those variables. But if you interchange the two, I'm probably not going to hold you accountable to using the right words. But I'm always going to. And I will, when I talk about your responses, if you say, we're going to talk about something called an explanatory variable, and then you say, it's the independent variable, I might say, we call that the explanatory variable in stats, but then that can be enough. Okay, so if you were to be like, this is qualitative data, I would be like, cool, we call that categorical data. But I'm never going to be upset about it because I know that some of these words and vocabulary have been ingrained in you in other courses. So basically, a categorical variable is one where, in layman's terms, we would say words are a response. Okay, and the easiest way to distinguish this is that it's words, but for instance, your grade level, I would also call a categorical variable, okay? And we usually describe categorical variables with percents. For example, we might say, 50% of Miss Meister's AP Stats classes are juniors. And so we wouldn't say the average grade level is 11.2. That doesn't help us very much, but describing with percents is describing each category with a percent feels a little bit better. Okay. We also have quantitative variable where the responses are numbers. So how many pets do you have? Everybody's responding with a number. That would be a quantitative variable. Now, between quantitative variables, we actually have two different kinds, and sometimes later on when we learn about the different types of analysis, we're going to want to know which kind are we talking about. Okay, we can either have a discrete variable or we can have a continuous variable. So a discrete variable, an example of a discrete variable is shoe size. An example of a continuous variable is the length of one's foot. And you might think, wow, these two things are very much related to each other, and they are, okay? However, when we go to buy shoes, you can buy a 7, you could buy a 7.5. But for a shoe size, there's no 7.234. However, the length of one's foot could be 7.324. I know I did those backwards. Inches. Okay? So for discrete variables, what that means is there's no in-betweens. And for continuous variables, you can run, like, in between, your response could be any number. Now, a lot of the way we measure things is, for instance, if I gave you guys a tape measure and you could measure the length of your feet, okay, that would be continuous, but on the tape measure it wouldn't, because you could go to, like, if your tape measure only has every quarter inch, then you would have to run to the nearest quarter inch. But the actual length of your foot, depending on the precision of your measurement tool, is continuous, okay? So this is all I have for today. Thanks for doing the survey, and I will see you guys tomorrow morning, or tomorrow afternoon.